You ever try to ship a snake? It's complicated. You need a very specific box, right? The temperature's got to be just so, it needs the right food. If you mess any of that up, things get ugly fast. Well, in the world of software, a complex application, it's kind of like that snake. And for years, developers have been trying to figure out the perfect box to ship it in. Today, we're going to talk about that box. It's called a container, and it solved a problem that drove developers crazy for decades.
This phrase. This is the sentence that has literally haunted software development for years. A developer builds something amazing, it runs perfectly on their laptop, but the second they try to move it to a real server, or even just their coworker's computer, boom, it all crashes and burns. This is the exact problem that a technology called containers was created to solve, once and for all.
So, to really get why containers are such a game changer, we've got to take a quick trip back in time. We'll start with that deployment nightmare, then we'll look at the first big solution that came along, virtual machines, and see why, well, they weren't quite enough. Then we'll dive right into the container revolution, the tool that made it all famous, and figure out why it basically runs the modern internet.
So, what's actually causing this nightmare? Well, it all comes down to one word: dependencies. See, your application, your snake, it doesn't exist in a vacuum. It depends on a specific version of a programming language, it needs certain libraries, special system settings. The moment you move it to a new server, that server might have a different version of everything. And that, my friends, is where you get total chaos.
Okay, so to try and fix all this chaos, the industry turned to this brilliant idea that had been kicking around for a while but was about to hit the big time. It was a technology that completely changed how we think about using computers, the virtual machine.
I mean, way back in the day, if you wanted to launch an application, you had to buy an entire physical server just for that one app. Talk about wasteful. Most of that expensive server's power just sat there doing nothing. But then, in the 90s, virtual machines, or VMs, showed up and let us slice up one big powerful server into lots of smaller virtual ones. And that was a massive leap forward.
And yeah, looking at them side by side, the difference is just night and day. The old way was simple, sure, but so inefficient. The VM way brought in this clever piece of software called a hypervisor. It sits on top of the actual hardware and basically just carves it up, creating multiple, completely independent virtual computers. Each one of these VMs gets its own full copy of an operating system, totally isolated from all the others.
Okay, so VMs were a huge step up, right? They solved that big efficiency problem, but they introduced a new problem. They came with this significant hidden cost, a kind of tax you had to pay for every single app you wanted to run.
And that baggage, that's the tax we're talking about. Because every single VM is a full-blown computer, it needs its own complete operating system, which can be gigabytes in size. It needs its own reserved piece of memory and processing power. It can take minutes just to boot up. All of that is just overhead. All of it happens before your app can even think about starting. So when you add it all up, this tax in resources, in time, and sometimes even in cold hard cash for licensing fees, it gets expensive fast. It's like building an entire self-contained refrigerated truck just to ship that one little snake box. You see where this is going, right? Most of your server's power was being wasted just running all those heavy duplicate trucks. There had to be a better way. And then came the better way. It was this huge aha moment for the entire industry, and it all started with one simple but really profound question.
What if we could have our cake and eat it too? What if we could get all the awesome isolation that a VM gives you, but without paying that massive resource tax? What if we could just get rid of that entire bulky guest operating system from the picture?
And this right here, this is the money shot. On the left, you've got the old virtual machine stack with that thick, heavy guest OS layer for every single app. Now look at the right. That's a container. See that? The guest OS is just gone. Instead of faking the hardware, containers fake the operating system itself. They all just share the same host OS.
And that is the secret sauce. A container is basically just your application and the stuff it directly depends on, all wrapped up together. It runs as an isolated little process that shares the core, the kernel, the absolute heart of the host machine's operating system. By just ditching that duplicate OS, it becomes unbelievably light and fast. This is the perfect box for our snake.
Now, this isn't some kind of black magic, right? It's all built on these really clever features that have been part of the Linux operating system for years. The first one is called namespaces, and it basically puts up virtual walls around each container so they can't see or mess with each other. The second is cgroups, and it acts like a resource cop, making sure no single container can hog all the server's power. It gives you all the isolation with none of the overhead. So, get this. The technology to do all this, it had actually been around for a while. But it was super complicated, something only the real wizards could use. Then, in 2013, a company called Docker came along and created a simple set of tools that made this amazing container technology easy enough for every single developer on the planet to use.
The first big idea they made easy was the image, and you can think of a Docker image as the blueprint or a detailed recipe for your container. It's just a simple text file that says, hey, start with this tiny version of Linux, then install Python, then copy my app code into it, and finally run this one command to start everything. It's kind of like a VM template, but way more efficient and super easy to share.
And this made the whole workflow just dead simple. First, a developer builds the image. That's the blueprint. Then they use the run command to launch a container, which is a live running instance of that blueprint. And you can run hundreds of identical containers from that one single image on any machine in the world that has Docker installed.
All right, so why does any of this matter? What's the big deal here? Why did this simple idea completely flip the software industry on its head? Well, it all comes down to a massive shift in two things: scale and speed.
I mean, the difference is just, it's absolutely staggering. A VM can take minutes to boot up. A container starts in seconds, sometimes even milliseconds. A VM image is measured in gigabytes. A container image is often just megabytes. And what that means is you can pack far more containers onto a single server than you ever could with VMs, which drastically cuts down on hardware costs.
So when you put it all together, what do you get? You basically get the best of all worlds. They're portable. That works on my machine problem? Gone. Solved. Because the container is the machine. They're incredibly efficient, saving tons of money on servers. They give developers incredible speed. And maybe most important of all, they guarantee consistency, from a developer's laptop all the way to production.
So we've figured it out. We know how to put our snake in the perfect, reliable, lightweight box. But you know, modern applications like Netflix or Google, they don't run on just one container. They run on tens of thousands of them. And that brings up a whole new question, right? If a container is the box, what acts as the giant automated warehouse that manages all of them? Well, that is a story for another time.